So here in this lecture we are going to learn about wave symmetries. Like if you use this type of symmetries for a waveform, you can easily write Fourier series. So there are mainly four types of symmetries for a function x of t. That is even symmetry, odd symmetry, half wave symmetry and quarter wave symmetry. So what is this even symmetry and what are the mathematics relations of Fourier series coefficients, that is an, a naught and bn. So even symmetry or mirror symmetry is happens when x of t equals to x of minus t. Okay, like an even signal. In this case the an will be given as 4 by t integral 0 to t by t x of t cosine of n omega naught t dt, and a naught is given by 2 by t integral 0 to t by 2 x of t dt. So bn is 0 in this odd symmetry case. Okay, if you apply, if you or otherwise if you try to find out bn for this kind of waveform, you will easily get it. Okay, so before finding bn, only you can say that bn is 0 for a even symmetry wave, right? That is the advantage of knowing all these concepts. So another one is odd or rotation symmetry. It is for the waveforms which are satisfying this condition, that is x of t equals to minus x of minus t. So here an equals to 0 and a naught equals to 0, but bn is 4 divided by t integral 0 to t by 2 x of t sine n omega naught t. Okay, right. The third type of symmetry is half wave symmetry. So here in this case, if x of t equals to minus x of t plus or minus t by 2, we can say that waveform is following half wave symmetry. Then the formulas are going to look like this. It is a naught equals to 2 by t integral of 0 to t by t x of t into cos n omega naught t minus x of t cos n omega naught t into cos n pi. Okay, and you need to observe this. This is going to become 0, like this an value is going to become 0 for even values of n, and going to become this value, that is 4 by t integral 0 to t by 2 x of t cos n omega naught t dt for odd values of n. Okay, still it is going to get simplified compared with even, right? Because if you see even symmetry, there you are having an, a naught and bn. Sorry, bn is 0. Here in case of half wave symmetry, an is there but only for odd values of n. In case of even symmetry, it is there for all values of n, but here it is there for only for odd values of n, right? So in this you can include a naught also. What will be the value of bn? So bn is going to exist for odd values of n like this, that is 4 by t integral 0 to t by 2 x of t sine n omega naught t dt, and for even values of n it will be 0. Okay, so as I said, a naught is 0 because 0 is even number, and so finally only odd harmonics are going to exist for this half wave symmetry type. Okay, then comes the fourth type of symmetry, that is quarter wave symmetry. So here x of t equals to x of minus t, or x of t equals to minus x of minus t, and in between these two any one condition will be satisfied. That means either that waveform is even or odd, and along with that condition it will also satisfy x of t equals to minus x of t plus or minus t by 2. Okay, that means a function f of t which has either even symmetry or odd symmetry along with half wave symmetry is said to have quarter wave symmetry. That means both previous conditions. So in the first case, if x of t is odd, that is minus x of minus t, and x of t is also satisfying half wave symmetry, let us say. So in case 1 we are considering it as odd signal and half wave symmetry, and in case 2 we are going to consider with even signal and odd symmetry, sorry, half wave symmetry. So in the case 1 an is 0 and a naught is 0. Okay, from the odd symmetry you can get this an equals to 0, a naught equals to 0, and bn is there, but it will be there only for odd values of n, and it is 8 by t, 0 to t by 4. Are you getting? Previously for half wave it is 4 by t, 0 to t by 2. Okay, but here in case of quarter wave it is 0 to t by 4, so it will be 8 by t, and it is only for odd values of n, because half wave symmetry is going to give only odd harmonics, that's why, right? So if it is even plus half wave, which is also comes under quarter wave symmetry, in this case you are going to have an values, right? Yes, that's it. That too only when n is odd, and a naught is 0, because that is 0 is an even number, and bn is anyways 0 from which symmetry? Bn is 0 completely for even symmetry. That's it. Very simple. You just note down all these and analyze once.